So in the last class, we were discussing the gravitational waves, okay, theory of gravity, and basically the geometric theory of gravity. And some of you have written the answers that I have given you regarding the blockchain and the cryptocurrencies. So I have checked two answers because they were in the PDF format, and those answers which were in the JPG format, okay, I cannot evaluate them digitally. And if you want that your answers, okay, they get evaluated, then please send them in the PDF format. Okay, and the maximum marks, the best answer, okay, the best answer will be awarded 50% of the marks. तो कोई भी गुस्सा मत होना कि इतना अच्छा आंसर लिखा है फिर भी आउट ऑफ 10 सिर्फ 5 मार्क्स ही अवार्ड किए गए. Even in the UPSC, they do not award more than 55 to 60% marks for the best of the answer. And please try to write in the paragraph form. The introduction, it should be a paragraph, and in the body part, please write in either in the paragraph form or you can write in points. और जब भी कोई पॉइंट्स में लिखेगा तो प्लीज डू नॉट यूज द बुलेटेड पॉइंट्स, डू नॉट यूज द एरोस, यूज द नंबर्ड पॉइंट्स 1 2 or 3. Okay, the idea is that we have to tell the examiner that we have covered this much dimensions. Okay, if you are giving the 6-7 points and in the next answer the next student has given only 4-5 points, okay, then he will be inclined to award you more marks. So always use the numbered points. You have to understand the psyche of the examiner as well. Okay, and you will improve only with practice. And Soumya Ranjan, he has written very good answers. And Kritika, if the points are less, then avoid using the numbers. And if you have enough content and you are sure about the content, then please use the numbered points. And if you have to deceive the examiner, do not use the numbered points. If you are beating around the bush, then please do not use the numbered points. And I also evaluated one answer from Ruxana. Ruxana, have you received the evaluated answer? I think, okay, Ruxana, you have not received it. Okay, I will check to that, but I have evaluated your answer and I have reverted it back. Welcome, Ruxana. So yesterday I was telling you that the theory of gravity, the Einstein's general theory of relativity, it is basically the geometric theory of gravity. And from the special theory of relativity that was published by Einstein in 1905 and the general theory of relativity that was published in 1915, we have, okay, we came to know that even the space has some kind of geometry, and not just the space, even the time, okay, time also has a geometry. And we have the phenomena of time warping and space warping. Okay, so the geometry of the space, it is affected due to the presence of mass, energy and momentum. Okay, this space, the geometry of the space is affected by the presence of mass and it is affected by the presence of energy. So near the heavier objects like the sun and the earth, okay, there is a change in geometry of the space. This space, it gets curved. We say that the space is curved. Okay, if the mass is not there, then the space is flat. If you are very far away from any massive object and there is no energy source, okay, surrounding you, then the space is flat. and if you have thrown any stone, okay, it will go in a straight line. But if the space is curved, okay, any particle left to itself will follow the curved path. Okay, take one more example. If you have a cricket ball, a tennis ball, what is the shortest distance between any 2 points? Tell me, what is the shortest distance between any 2 points? Yes, Disha, displacement is the shortest distance, but like on a plain paper, the shortest distance between any 2 point A and B, okay, you will see the straight line joining the A and B. Since the surface of the sphere is a curved surface, okay, the shortest distance between any 2 points A and B, it will be this curved part. Try to draw a line, ठीक है, एक क्रिकेट बॉल लीजिए, टेनिस बॉल लीजिए और उसके ऊपर कोई भी 2 पॉइंट मार्क करिए एंड देन ट्राई टू कनेक्ट दोस 2 पॉइंट्स. ओके, you will have a curved line because that is not a flat surface. I will give you more examples. Okay, take a flat piece of paper, a rectangular paper. Okay, you can create a cube from it by cutting the pieces of paper and you can arrange them in a cube. Okay, and you can make a cylinder out of it. So basically these are the examples of this is the flat geometry. And but you cannot cut a sphere and you cannot, okay, you cannot create a 2D sheet from a sphere. Sphere is basically a non-developable shape. ओके, एक प्लेन शीट ऑफ पेपर से तुम उसको उससे ऐसे एक स्फीयर डेवलप नहीं कर सकते हो और एक स्फीयर को काट के उससे एक प्लेन शीट हम डेवलप नहीं कर सकते हैं. सो द शेप ऑफ स्फीयर इट इज यूनिक बिकॉज द ज्योमेट्री ऑफ द स्फीयर इज डिफरेंट. तो ज्यादा इसमें जाने की जरूरत नहीं है. द पॉइंट इज कि स्पेस की एक ज्योमेट्री है. ओके, देयर इज अ स्ट्रक्चर ऑफ द स्पेस and likewise same is for the time. Time also has geometry. Near the massive objects, time it runs slower, and near the lighter objects, the time it runs faster. So if you will go from the earth to the sun, and the clocks they will get slower. Okay, and the space is more curved near the sun than the earth because the sun is massive. Because the sun is massive, so the space is more curved. So in the fabric of the space, the heavier objects they can create a ripple. Okay, so the gravitational waves, these are the ripples in the fabric of space and time. Everything will be squeezed, everything will be stretched, that will come in the way of the gravitational waves. Okay, earlier we only know that the energy it gets dissipated by way of electromagnetic radiation. जब भी किसी हम अगर किसी भी चीज को गर्म करते हैं, जैसे अगर लोहे को गर्म किया, then it gets red hot and it starts emitting some kind of radiation. That is why it is appearing as glowing, because it is emitting radiation. Okay, so everything it dissipates energy in the form of electromagnetic radiation. But there is one more way to dissipate the energy, and that way is the gravitational waves. Okay, these are the waves in the fabric of the space, and through this way also the energy it can get dissipated. We will see how. समझ में आ रहा है ना? सिर्फ 2 पॉइंट समझने हैं. किसी को कोई प्रॉब्लम? देखो थोड़ा सा यहाँ पे प्रॉब्लम बिल्कुल होगी, क्योंकि ये आइंस्टीन के आइडियाज हैं, उस टाइम पे भी लोगों को नहीं समझ में आए थे, और आइंस्टीन कुछ चीजों से खुद भी कंफर्टेबल नहीं थे, क्योंकि ये जो कॉमन नोशंस हैं उनसे थोड़ा परे जाके आइडियाज हैं। ओके, दिस इज अबाउट द स्ट्रक्चर ऑफ द यूनिवर्स। ये हमारे यूनिवर्स की रियलिटी है और इनको एब्जॉर्ब करने में थोड़ा टाइम लग सकता है। वन रियलिटी ये थी कि नथिंग कैन ट्रेवल फास्टर देन द स्पीड ऑफ लाइट। ओके, दैट वाज वन, एंड दैट वाज द आउटकम ऑफ स्पेशल रिलेटिविटी। और एक और चीज मैंने बताई थी, दैट मास एंड एनर्जी दे आर इक्विवेलेंट। okay, mass and energy, they are the manifestation of the same form, and they are interconvertible. The energy, it can be converted into mass, and the mass can be converted into the energy, and the equation was E equals to mc square. Okay, and nothing can travel faster than the speed of light, so that means there is something unique about this space, that it cannot allow anything to travel faster than the speed of light. Take an example for what? You need
So you
example.
told mass can be converted into energy and energy can be for that, sir. But I didn't understand, sir. That's it.
You have learnt about the fusion reaction in the schools, in the high school, Nikhil. Have you heard about the fusion reactions?
Ah, yes, sir. Yes, sir.
Okay, so in the fusion reaction, or even in the nuclear fission reaction, in fission reaction, a nuclei, a heavier nuclei, it will break into the smaller nuclei. In the nuclear fission, a heavier nuclei, it breaks into the smaller constituents.
Okay, sir.
No, Kritika, mass energy is basically, mass energy equivalence is see a 1 kg body, 1 kg body, it is equivalent to 1 kg into the c square. It is equivalent to that much amount of energy. Okay. So in the fission, a heavier nuclei, it breaks into two lighter nuclei. This is the fission. And in the fusion, two lighter nuclei, they make up a bigger nuclei. That is the fusion reaction. Okay, in case of fusion, suppose this body has some mass. It has the mass m1, and the second body has mass m2, and the fusion product, it has mass capital M. Okay, then ideally we should have m1 plus m2 equals to m. Okay, ये बात सबको समझ में आई, because m1 and m2 are combining and they are producing another mass capital M. Ideally m1 plus m2, it should be equal to m. Okay, but m1 and m2 in reality, m1 plus m2 is greater than m. So where did that mass go? The mass of the constituents combined, it is more than the mass of the new body formed. So this thing is known as the mass defect. Okay, A and B has combined to form a new unit C, but the combined mass of A and B, it is more than the mass of C. So this phenomena is known as the mass defect. And this mass defect, okay, this difference in mass, if it is multiplied by C square, delta M into C square. Okay, so this much of energy is released in the fusion reaction. That mass defect, जो mass missing था, that gets converted into the energy. The mass defect is equivalent to the energy delta M into C square. और fusion के अंदर जो energy produce होती है, that is this much energy. So fusion के अंदर जो energy produce हो रही है, that is because of the mass defect. Okay, Nikhil? So जो mass गायब है, that mass gets converted into energy equivalent energy. Okay, and that equivalent energy is delta m into c square. No, Kritika, rest mass is, see, I told you that the physical quantities, okay, physical quantities, if you are measuring anything, if you are measuring time, time is a physical quantity. If you are measuring length, length is a physical quantity. And if you are measuring mass, mass is also a physical quantity. So, okay, so in physics, we measure the physical quantities, and rest mass, okay, टाइम, मास, लेंथ, ये सब फिजिकल क्वांटिटीज हैं और इनकी वैल्यू डिपेंड करती है ऑन द ऑब्जर्वर, किस रेफरेंस फ्रेम से हम मेजरमेंट कर रहे हैं. सो रेस्ट मास इज बेसिकली दैट मास जब वो पार्टिकल रेस्ट पे रखा है. ओके, यू आर ऑब्जर्विंग अ पार्टिकल एट रेस्ट, देन दैट मास इज द रेस्ट मास. इफ द पार्टिकल इज इन मोशन, then its mass will be different. So we have defined rest mass as the mass when the particle is at rest as observed by the observer. तो ज्यादा जाने की जरूरत नहीं है. Energy is equivalent to mc square. Okay, और जब भी heavier masses, heavier objects, they will collide, okay, and they will move at great speed through the fabric of the space, then there will be ripple in the fabric of the space and time, okay, and we will have the gravitational waves. ठीक है, तो एक बात हमने पकड़ी कि स्पेस एंड टाइम का एक फैब्रिक है. ओके, एंड जब भी हैवियर ऑब्जेक्ट्स पास होंगे, then the fabric it will oscillate. There will be some kind of ripple in the fabric of space time, and those ripples, they are known as the gravitational waves. And these, you can understand them that these are similar to the waves that are produced in a pond. Okay, if you will disturb the surface of the pond, then there will be waves in it. किसी को इसमें कोई प्रॉब्लम? अगर हम इसमें ज्यादा डीप में जाएंगे, एस्ट्रोनॉमर थोड़े बनना है. ओके, द इक्वेशंस, दोज इक्वेशन जो इस सब को डिस्क्राइब करती हैं, दीज इक्वेशंस दे आर रिटन इन द टेंसर फॉर्म. ओके, so it is very difficult to interpret them, so don't go into that. ये काम हमको एस्ट्रोनॉमर्स पे छोड़ देना है, और लेकिन वहां से जो आउटकम निकल के आया है वो हमको पता होना चाहिए. Okay, the conclusions that the scientists have drawn from the data of the universe, okay, we have to understand those conclusions, that even the space has a structure. Okay, the space can be curved, okay, and nothing can travel faster than the speed of light. And the gravitational waves, they are generated by the heavier objects. When the heavier objects, they move rapidly through the space, or when the heavier objects collide, then we will have the gravitational waves. Clear? So the gravitational waves, they are formed in the giant explosions. Okay, when a star explodes, then we have the supernova. The giant explosion is known as supernova, and these are formed when two stars, they will orbit each other. Okay, when two stars, they orbit around a common point, it is known as a binary system. And when these stars, they rotate very rapidly, then the gravitational waves are formed. And these are also formed obviously by the merger of the black holes, because black holes, they are very massive and they are dense objects, and by the merger of the black holes, the gravitational waves, they are formed. Okay, so what is the supernova? Supernova, it is an event in the, okay, when the star, the life of the star, it is going to end, then this event supernova happens. Yes, no, we are dying of a star. Okay, so in the older age of the star, when much of the nuclear fuel it gets burned, then this event supernova, it happens. Okay, when the core of the star, it runs out of the nuclear fuel, then it starts eating the mass from the surrounding layers of the star. And because of some kind of stability, because of some kind of instability, the star explodes. So these events happen towards the end of the star life. Okay, so after this event, after the supernova, either a neutron star will be formed or a black hole will be formed. Okay, so we will study that later. But in a supernova, in a star explosion, okay, the star material, it is ejected into the space. The debris or the star material, it is ejected into the space, and most of the elements that have their origin inside the core of the star, okay, it gets scattered, it gets distributed in this space. एंड जो भी प्लैनेट्स वगैरह फॉर्म हो रखे हैं, जो भी एक्सोटिक एलिमेंट्स अर्थ पे मिल रहे हैं या कहीं और भी मिल रहे हैं, ओके, सो दिस मटेरियल दिस हैज ओरिजिनेटेड फ्रॉम द कोर ऑफ द स्टार्स. So that is why we are studying all these stars. There is a reason that we are studying the universe, we are studying the space, क्योंकि ultimately the elements, all the elements, they have formed in a way inside the core of the stars. Okay. Yes, Nikhil. Initially, all the stars have hydrogen, and when the hydrogen it gets exhausted, then we have the helium, and helium will fuse to produce the carbon, and then the carbon will fuse to produce the oxygen. Okay, and finally the process stops. So hydrogen is the simplest element, and hydrogen gases, they are the major nuclear fuel. So there are two categories of the black holes. One black hole which have masses which is only a few 5 times massive than the sun. Okay, a few solar masses, जिसका mass, okay, 5-10 times ही होगा sun के. One black hole is of that category, and these are known as the, okay, simple the black holes. And then we have the supermassive black holes which are billion times heavier than the sun. Okay, supermassive black holes, they are a billion times heavier than the sun, and the black hole that is situated in the Milky Way galaxy, at the center of the Milky Way galaxy, what is the name of that black hole? What is the name of that black hole which is situated in the
Sagittarius A.
Yes, Palak, that is Sagittarius A. But recently we have found out that we have also the intermediate mass black holes. Earlier it was thought that only we have the supermassive black holes, or we have the, okay, these lighter black holes, but we also have the black holes with the intermediate solar masses, and they range from some, okay, 100+ solar masses. So the recent discovery of the gravitational wave in the year 2019, okay, we have discovered gravitational wave in the year 2019, and from that data we have inferred that the black hole that was formed that had this mass around 142 times that of the sun's mass. So एक और साइंटिस्ट के सामने प्रॉब्लम आई है, that how to define or how to explain these intermediate mass black holes. Okay, so रिसर्च का काफी स्कोप है एस्ट्रोनॉमी के अंदर. There are a lot of unanswered questions, and the community of the astronomers, okay, the cosmologists, they are searching answer for all these questions. Nitin, how do we know about the structure of the atom? Okay, you remember the Rutherford experiment? What Rutherford did? He bombarded the gold foil, okay, with the alpha particles, and from that data, they infer that there is a heavy nucleus at the center. Okay, and in an atom we have a lot of empty space. Okay, and then we study the gases like the hydrogen and the radiation that is emitted by such gases, and then we studied that radiation and we get to know that there are basically energy cells around an atom. Okay, so basically we are inferring all this from the data that we are collecting from all these experiments. ठीक है, इलेक्ट्रोमैग्नेटिक रेडिएशन से जो भी हमको डेटा मिला है, and from that we get to know about the structure of the, okay, the structure of the crystals, and we get to know about the structure of the atoms, and in a similar way the waves that we are detecting from the universe, from that data we can infer something about the structure of the universe, and even these giant objects like the black holes, like the neutron stars, in a similar way. Okay, because they are sophisticated theories, in fact the sophisticated mathematical theories. Okay, they use the theory part and they use the data that they receive, and using the theory and data they come to these conclusions. Okay, for that you will have to study the general theory of relativity at the basic level, and then you will have to study the astronomy. Okay, after you have learned about the basics of the GTR, then you will learn about the basics of the astronomy, how to make calculations, okay, how to use this data. So all this is very sophisticated work. जैसे एटम्स के केस में था, रदरफोर्ड ने एक सिंपल एक्सपेरिमेंट से डिटेक्ट किया, तो उसी तरीके से यहाँ पे भी होता है. Yes, Nitin, I am coming to that. There is LIGO detector. अच्छा, एक सिंपल सा एग्जांपल सुनो. अगर किसी चीज का स्ट्रक्चर हमको जानना है, देन हम क्या करेंगे? बचपन में क्या करते थे? कुछ नया खिलौना आया है या कोई नया इंस्ट्रूमेंट है, उसको खोल देते थे. ठीक है, टू नो अबाउट द स्ट्रक्चर, इसके अंदर क्या है. द सेम, यस कृतिका, वी विल ब्रेक इट. द सेम थिंग इज डन बाय द साइंटिस्ट. रदरफोर्ड ने क्या किया? ही बॉम्बार्डेड द गोल्ड फॉइल यूजिंग द alpha particles. So basically he is breaking the gold foil. Okay, to know about the structure of the atom, he is bombarding it with the alpha particles. Okay, and these things, these gravitational waves and the lights that are coming from the distant galaxies, so from that data also we infer about the structure of the galaxies. Okay, तो सब कुछ इन्फर उसी डेटा से कर रहे हैं, एंड फॉर दैट, ठीक है, सोफिस्टिकेटेड थ्योरीज ऑलरेडी मौजूद हैं. आइंस्टीन लोगों ने यही सब किया, उन्होंने थ्योरीज डेवलप की, एंड नाउ द साइंटिस्ट दे आर एक्सप्लोरिंग द स्पेस लुकिंग फॉर डेटा टू टेस्ट द थ्योरी ऑफ द आइंस्टीन. एंड आइंस्टीन हैज, he predicted something in the 1915 and it was detected in 2015. So Einstein was right. And even in the 1930s and 40s, Einstein himself doubted the existence of the gravitational waves. Okay, he was himself uncomfortable with the idea of the gravitational waves. So please write about the supernova. It is an explosion at the end of a star's life, and a supernova is basically a star whose brightness increases greatly. Okay, because of the catastrophic explosion, the brightness of the star, it increases greatly, and most of the stellar mass is ejected in this process. Okay, and from that exotic mass that is ejected from the star, okay, the different elements, they then combine to form other planets or other things in the universe. So everything that is present in the universe, okay, most of the elements, they have formed inside the core of the stars. And from the study of the supernova, the light that we have detected from the supernova. So by using the Hubble Space Telescope, we infer that the universe is in fact expanding. So theoretically, we never expected that the universe, okay, it will expand indefinitely. But using the data from the supernova, the scientists, they have found out that the universe is expanding, and it is not just expanding, it is expanding at an accelerated pace. No, Nikhil. If the sun dies, then we'll die. It is as simple as it is. Okay. But the sun, it will die after billions of years. See, after millions of years, the sun, it will convert into the red giant star. The sun will become the red giant, okay, after millions of years. And when it will become the red giant, now the earth is rotating around the sun, then the earth, it will be engulfed by the red giant, okay. And at that time, after millions of years, the existence of earth, it will end. Yes, Aditi.
Nothing, I just reconnected.
Okay. So we also have a star that is known as the white dwarf, and a white dwarf is also formed at the end of a star life, and it is found when most of the nuclear fuel is used. Okay. So at the end of a star life, okay, for the smaller stars, that are less heavier, so those stars, after using most of their fuel, so these stars, they do not explode, and their outer layers, they vanish after some time, okay, and most of their nuclear fuel is already used, so the fusion reaction inside the core, it stops. ठीक है, तो व्हाइट ड्वार्फ्स वो स्टार्स हैं जो थोड़े उतने हैवी नहीं है, ओके, दे आर ओनली अ फ्यू सोलर मासेस. नो निखिल. Sun is also a star, okay, which is, see, sun will not convert into the white dwarf. Sun will ultimately convert into the white dwarf, but it will go through the stage of the red giant. Okay. First it will become the red giant, and finally it will become the white dwarf. But sun, it will not go through the supernova because it does not have enough mass. Yes, Nikhil, just like our sun. So our sun will someday convert into the white dwarf. Okay, and in the white dwarf, in the core of the white dwarf, the fusion reaction, it stops. Okay, the fusion stops. And when the fusion stops, so it will start the cooling process in the star, it will start. Okay, जब fusion reaction बंद हो जाएगी, then the star, it will start to cool down, and it will take billions of years for the star to get cooled down completely. And that is why, because they are now cooling, they are the cooling stars, they have a faint glow. So gravitational waves, they are formed by the heavier objects, and because these objects, they are located very far away from us, so when these waves, they will reach us, they will get very weak. Okay, we receive only the weak gravitational waves, and for this reason we need sophisticated instruments, okay, to detect the gravitational wave on the earth. So these waves, they become weak as they reach earth, and we need devices which can measure the length to the accuracy of Okay, you should be able to measure the 1000 part of the diameter of the proton. Okay, instrument की sensitivity इतनी होनी चाहिए that you can measure the lengths which are equivalent to 1/1000 of a diameter of the proton. ठीक है, and the diameter of the proton, it is 0.84 Fermi. अब कोई मुझे बताएगा फर्मी कितना होता है? 1 Fermi is equivalent to, yes, 10 to the power minus 15. Soumya Ranjan is right. If it is 10 to the power minus 15 meter, 1 Fermi is equivalent to 10 to the power minus 15 meter, and this is basically 0.84 Fermi is the diameter of a proton. And your instrument, it should be sensitive enough to measure the 1000 part of the diameter of the proton. ठीक है, your instrument should be sensitive enough to measure the length equivalent to the 1000 part of the diameter of a proton. Okay, so one thing is very clear, that we need sophisticated machinery, sophisticated instrument to measure the length of this size. So let us now learn about the detection of the gravitational waves, and for the first time they were detected in 2015, and the date was 14th September 2015. Okay, and the name of the gravitational wave is gravitational wave. First we will have the year, then we will have the month, and then we will have the date. So this is how the gravitational waves they are named. This is the date, this is the month, and this is the year. Okay, and we have also received one gravitational wave in 2019, and the name of that wave is, it was detected on 21st May, so that was GW. Because it was detected in the year 2019, so we have the 19, and the month was May, and date was 21. So the gravitational wave, the largest gravitational wave that we have detected, it was on 21st May 2019, and name of that gravitational wave was GW190521. And the first gravitational wave that we detected on Earth, that was on the 14th September 2015, and its name was gravitational wave 150914. The last two digits is the date, the middle two digit is the month, and the first two digit they correspond to the year. Okay. So the first gravitational wave was detected on the 14th September 2015, and it was detected by a network of two advanced detectors, and those detectors they are named LIGO detectors, LIGO, and please write LIGO is laser interferometry, gravitational observatory. Okay, laser interferometry, gravitational observatory. So these LIGO detectors, they were designed to detect these gravitational waves, and 2015 से पहले they were looking for the gravitational waves, but they failed. उसके बाद इनके टेक्निकल स्ट्रक्चर में थोड़े बहुत चेंजेस किए गए, एंड आफ्टर दैट जब फर्स्ट टाइम इनको रन किया गया, ओके, क्लोज कर दिया गया था 2010 के अराउंड, एंड आफ्टर द 5 इयर्स साइंटिस्ट सब ने स्पेकुलेट किया कि हम लोग क्यों डिटेक्ट नहीं कर पाए, कि स्ट्रक्चर में कहीं ना कहीं कुछ कमी है। देन उसके बाद रीओपन इसको किया गया, री-रन किया गया पूरे डिवाइस को 2015 में, एंड दे वर एबल टू डिटेक्ट द ग्रेविटेशनल वेव्स। ओके, क्योंकि मेजर क्या करना है, वी हैव टू मेजर दी 1000 पार्ट ऑफ द डायमीटर ऑफ अ प्रोटॉन। हमारा इंस्ट्रूमेंट इतना सेंसिटिव होना चाहिए कि हम मेजर कर लें दी 1000 पार्ट ऑफ द डायमीटर ऑफ अ प्रोटॉन। सो द फर्स्ट डिटेक्टर, it was stationed at, it is stationed at the Hanford. Here we have the Hanford, okay, in the Washington state. Hanford is in Washington state, and there is difference between the Washington state and the capital of USA, Washington DC. Okay, so on the western coast we have the Hanford, and the Louisiana reactor, it is Louisiana detector. Okay, it is located in the southern part of USA. Okay, so these two detectors, they were able to detect the gravitational waves in the 2015, and these detectors, they are using the Michelson interferometer. The device that they are using is, or the technique that they are using is, that is the Michelson interferometer. Okay, so we have two LIGO detectors in the USA. One is in Hanford, and Hanford is in the Washington state, and other is in Livingston, and Livingston is in Louisiana, USA. Okay. So LIGO is for Laser Interferometer Gravitational Wave Observatory, and this LIGO is built by the California Institute of Technology in California and the Massachusetts Institute of Technology in the Boston. Okay, MIT Boston में है, and Caltech is in California. So ये पूरा LIGO, इसको बनाया भी इन्होंने एंड इसको ऑपरेट भी ये दोनों यूनिवर्सिटीज, दोनों कॉलेज कर रहे हैं. Okay, and this is funded by the National Science Foundation of USA. The funding is provided by the National Science Foundation USA. So in the September 2015, it received a signal, and that signal, it originated from the merger of two medium-sized black holes. Okay, and these black holes, they were situated 1.3 billion years away from us. यानी कि ये मर्जर 1.3 बिलियन ईयर्स पहले हुआ था, और तब से ग्रेविटेशनल वेव ट्रेवल कर रही है, और हम तक वो 2015 में पहुंची. ओके, द ग्रेविटेशनल वेव रीच्ड अस आफ्टर द 1.3 बिलियन ईयर्स. So this is the Michelson interferometer that these waves are using. Okay, so in the Michelson interferometer, here we have one laser, and a laser beam is, okay, a laser beam is it gets split into two parts by the use of some mirror. Okay, a mirror is used to split the laser beam into two parts. The one part, it went straight, and the other part, okay, and these two beams, they are at the right angle. The angle between the two beams is 90 degree, and each of the arm is 4 kilometer long. Okay, so each of the arm is 4 kilometer long, and as the laser wave, it travels and it comes back, and this wave, it also travels and comes back. So they again combine at this point. Okay, after traveling the 4 kilometers, okay, in both the arms, the laser beam, it again combine at this point, and here we have the detector. So this detector, it receives the signal. Okay, so the detector, it receives the signal, and on the detector we have no signal when there is no gravitational wave. You all must have learnt about the interference phenomena. see if two waves, they reinforce each other. Okay, the crest is along the crest, and okay, the depression is along the depression. Then in this case, the trough is along the trough and the crest is along the crest. Then we have the interference. Okay, the two waves, they supplement each other and the signal, it gets larger. Okay, but if the two waves, they are opposite means the one is having the crest and one is having the trough, then in that case these two signals, they cancel out and we get no signal. ओके, सो इन्होंने इंस्ट्रूमेंट को इस तरीके से अरेंज किया, एक लेजर बीम इस डायरेक्शन में जा रही है, सो दिस इज वन पल्स लाइक दिस, एंड एक लेजर बीम इस डायरेक्शन में जा रही है, सो दिस इज आल्सो वन पल्स लाइक दिस, एंड व्हेन दे आर अगेन मीटिंग एट दिस स्प्लिटर, जब ये दोनों वेव्स अगेन स्प्लिटर पे मिलेंगी, सो अरेंजमेंट इस तरह का है दैट दे विल कैंसिल आउट ईच अदर. द अरेंजमेंट इज सच दैट द बीम्स, दे विल कैंसिल आउट ईच अदर. ठीक है, कोई दिक्कत? एक बीम, वन वेव, इट गेट्स स्प्लिट इनटू टू पार्ट. ठीक है, सो एक वेव को स्प्लिट किया टू पार्ट्स में, एंड व्हेन द वेव्स, दे आर अगेन मीटिंग एट दिस स्प्लिटर. ओके, सो दीज टू वेव्स, दे आर out of phase such that when this one is having the crust at the detector, this one is having the trough, and when these two will combine, then we will have no signal because they will exactly cancel out each other. Arrangement हमने इस तरीके से किया है that the two waves, they will exactly cancel out each other. Now imagine if a gravitational wave is passing through the earth. Imagine that a gravitational wave is passing through the earth, then both of these arms, okay people, we are using the laser beam in this experiment. Okay, we are using the laser beam, and we all know that the laser is also a kind of wave. Okay, so here we have a splitter, and because of this splitter, this beam gets split into two parts. One part goes along this arm and one part goes along this arm. Okay, so after traveling through this arm and reflecting from this mirror, and this one reflects from this mirror, these two waves again meet at this point. The arrangement is made such that the one wave has this profile and the other wave has this profile. Okay, if this wave is having a crest at the location of this splitter, then the second wave is having a trough at the location of this splitter, and when the two waves, they will combine, they will exactly cancel out each other and we will have no signal. Okay, you all must have studied interference in your school, so these two waves, they will cancel out each other. इसको बस समझ लो, इसको नोट नहीं भी करोगे तो भी चल जाएगा, बिकॉज यूपीएससी ये कभी नहीं पूछने वाली है. ठीक है, मैं सिर्फ बता रहा हूं कि ग्रेविटेशनल वेव्स को डिटेक्ट कैसे किया है. ये यूपीएससी के हिसाब से यूपीएससी बस पूछेगी कि ग्रेविटेशनल वेव्स को डिटेक्ट करना क्यों इंपॉर्टेंट है, इसके यूनिवर्स के लिए इंप्लीकेशंस क्या क्या है. ओके, वो कभी नहीं पूछेंगे कि कैसे डिटेक्ट किया, बस इतना पूछेंगे कि व्हाट इज द फुल फॉर्म ऑफ LIGO एंड व्हाट डिवाइस they were using. So they were using the Michelson interferometer. तो मैं यहाँ पे था, when these two waves, they will combine, so they will produce no signal. So detector, no signal will be detected at the detector. But when the gravitational wave is passing through the earth, okay, these arms, the gravitational wave is passing through the earth, this arm it will stretch and it will compress as the wave will pass through the earth. Okay, the length of the arm, it will change. ठीक है, ये बात भी सबको समझ आई. The length of the arm, it will also change when the gravitational wave will pass through the earth, and when the length of the arm, it will change, then these two waves, they will be Okay, they will be out of phase and some signal will be detected here, because in that case the two waves, they will not exactly cancel out each other. Okay, उनका synchronization miss हो जाएगा and the two waves, they will not exactly cancel each other, and because they are not exactly cancelling each other, we will have some signal, and the scientists have detected this signal, and for 4, 5, 6 months then they have analyzed this data, और scientists ने संतुष्टि की कि this signal was not due to any earthquake activity. Okay, and this signal was not due to any kind of distortion, and they have verified it multiple times. It was because of the merger of two black holes. Okay, they also made some calculation using the general theory of relativity. Sophisticated calculations were involved. Okay, hundred thousands of scientists, they were involved in this, and they have verified that indeed the gravitational waves was passing through the earth. Okay, the length arm, this 4 kilometer length arm, the length of the arm, it changed and we detected the gravitational waves. ये समझ में आया? तो जैसे ही लेंथ थोड़ी सी भी चेंज होगी, ओके, वी विल रिसीव, द डिटेक्टर विल रिसीव अ सिग्नल because the waves will be out of sync. So this is how the gravitational waves were detected, and the LIGO detectors, they are very sophisticated, okay, very sophisticated labs, and these tunnels हाई एंड इंजीनियरिंग का यूज करके टनल्स बनाई गई हैं, एंड ईच ऑफ दिस टनल इज 4 किलोमीटर लॉन्ग. ओके, एंड लेजर्स, सोफिस्टिकेटेड लेजर्स फॉर यूज. सो डिटेक्शन नहीं हो पाई ग्रेविटेशनल वेव्स की, बट स्टिल द फंडिंग कंटिन्यूड एंड दे फाइनली डिटेक्टेड इन 2015 द ग्रेविटेशनल वेव्स. So this detector is sensitive enough to measure the length of the 1000 time of the size of a proton, and the black holes by the merger of which the gravitational waves were detected. These gravitational waves were formed by the merging of two black holes of masses, one having the 29 solar mass and the other having the 36 solar mass. अब इनको ऐड करोगे तो कितना आएगा? 65 solar masses. Okay, but the mass of the new black holes that they have detected is, it is 62 solar masses. So the rest three solar masses, okay, they have went into the energy. That energy has been released in the form of the gravitational waves, energy equivalent to mc square, where m is equivalent to 3 solar masses. Okay, so this much amount of energy, it gets released in the form of the gravitational waves. Okay, so Nikhil, this is the second example. The two black holes, one with the 29 solar masses and the other with the 36 solar masses. Two such black holes, they combine, and a black hole which is 62 times massive than the sun. Okay, such a black hole is formed. Solar mass is the mass equivalent to one sun. Okay, if any object has one solar mass, that means that mass of that object is equivalent to the sun. So because the black hole has a mass of 62 solar masses, so it is 62 times heavier than our sun. Okay, Nikhil. So a black hole whose mass is 62 solar masses is formed by the merger of two smaller black holes, and in this event, the energy which is equivalent to 3 solar masses, that gets released in the form of gravitational waves. So energy kitni thi? 3 solar masses into c square. That much of energy gets released in the form of the gravitational waves. Okay. अब किसी को कोई प्रॉब्लम हो तो ये बताओ. और यूपीएससी में कोई डायग्राम बनाने को नहीं बोलेगा, ओके, हाउ दे हैव डिटेक्टेड द ग्रेविटेशनल वेव्स वो भी नहीं बोलेगा, बट मैंने एक्सप्लेन इसलिए किया, यू विल अंडरस्टैंड, ओके, दीज थिंग्स, यू विल हैव अ क्लियर पिक्चर ऑफ व्हाट इज हैपनिंग, okay, what the scientific community is trying to achieve, you will have a clearer picture. तो किसी का कोई डाउट आज की क्लास से रिलेटेड, कल की क्लास से रिलेटेड या स्पेस टाइम ज्योमेट्री से रिलेटेड अभी भी कुछ हो, देन यू कैन आस्क इट. ओके, गुड. So what is the importance of these gravity waves? Okay, we can detect events that would otherwise leave little to no observable light. Okay, earlier we were discovering new things by observing the light coming from these objects, but what about those objects which cannot emit light? So by the use of the gravitational waves, we can infer, okay, we can deduce some information about such objects which cannot emit light. Okay, and it can also happen that due to some objects the light is not reaching the earth, any electromagnetic radiation from any object is not reaching the earth, because the light, it interacts with so many things. Light interacts with matter, and it can happen that the light is not able to reach the earth, but we are sure that gravitational waves will definitely reach the earth. Nikhil, natural calamities, they are easier to detect. Okay, we can easily detect the earthquake, but it is very difficult to detect the gravitational waves. Okay, the scientists, they were not interested. The cosmologists, they are not interested in the earthquakes. Okay, we can easily detect the earthquakes, but it is not very easy to detect the gravitational waves. You can easily detect the earthquake, okay, by the vibration of the ground. Even we can feel it. So we do not need any sophisticated instrument to, okay, to detect the earthquakes. But for the gravitational waves, we need sophisticated instruments, and because these things that are producing the gravitational waves, strong gravitational waves, they are situated very, very far away, 1.3 billion years. Okay, if this something, it travels at the speed of light, that will reach to us in 1.3 billion years. So this is all for today. We will continue from here tomorrow, and you can come up with your doubts tomorrow, or you can send those doubts to Jitin sir.
Ask them to wear mask while attending the class.
And the management has said that you have to wear your masks, okay, while attending the classes. So from the next classes from tomorrow, you have to wear your masks. So I am ending the session. Goodbye. Take care.
मजाक भी इतना seriously क्यों बोल रहे हैं?
Sir, इनको